20 years of ocean currents. What climate activists got wrong for over 2 decades, ocean currents have been central to climate change discourse, largely due to their vital role in regulating the Earth's temperature and carbon cycle. The narrative promoted by climate activists has rightly emphasized the significance of these currents, but certain key assumptions and predictions over the past 20 years have proven to be either overly simplistic or flawed. This chapter explores what climate activists got wrong about ocean currents, highlighting the complexities that were overlooked, misunderstood, or ignored. Oversimplification of the thermohaline circulation. One of the most significant misunderstandings in climate activism has been the portrayal of the thermohaline circulation, often referred to as the global conveyor belt. This massive system of deep ocean currents, driven by differences in water density due to temperature, thermo, and salinity, haline, was often used as a metaphor for the fragility of the Earth's climate system. Activists commonly warned of an impending collapse of the North Atlantic Current, part of the thermohaline system, predicting that such an event would lead to catastrophic cooling in Europe. The 2004 Hollywood movie The Day After Tomorrow amplified these concerns, leading to public panic that a rapid shutdown of this current could trigger a new ice age. While it is true that changes in ocean circulation could have profound effects on regional climates, the timescale and probability of such events were often exaggerated. In reality, the thermohaline circulation is not as delicate as previously feared. Recent studies have shown that, while the system is slowing down due to the melting of polar ice, this process is happening much more gradually than activists initially suggested. Predictions of an imminent collapse were premature. Instead, the weakening of the currents is likely to take place over centuries, not decades, giving more time for adaptation and mitigation strategies. Underestimation of regional ocean currents. While global models and broad-scale predictions about ocean currents have dominated the conversation, regional currents have often been overlooked. The focus on major systems like the Gulf Stream or Antarctic Circumpolar Current meant that smaller but no less critical regional systems were ignored. For example, the role of equatorial and coastal currents, which significantly affect localized weather patterns, marine ecosystems, and fishery productivity, has not received the attention it deserves. Activists often failed to communicate the nuanced impacts of regional currents, such as the upwelling systems that support large fisheries off the coasts of Peru and California. These systems are highly sensitive to climate change, and shifts in wind patterns or ocean temperatures can disrupt entire ecosystems, with cascading effects on food security and local economies. Overemphasis on warming and neglect of oceanic feedback mechanisms. One of the dominant narratives in climate activism over the past 20 years has been the warming of the oceans, with a strong focus on rising sea surface temperatures. While it is true that the oceans are absorbing much of the excess heat trapped by greenhouse gases, the focus on temperature rise alone missed a critical aspect: oceanic feedback mechanisms. Oceans play a key role in carbon sequestration, with currents facilitating the transfer of carbon dioxide from the atmosphere to the deep ocean. However, as climate activists primarily focused on surface-level warming, they overlooked how changes in ocean currents could alter the efficiency of this carbon sink function. Slower ocean currents mean less mixing between the surface and deeper waters, which could result in more carbon dioxide remaining in the atmosphere, accelerating climate change. This potential feedback loop was not well communicated to the public. Moreover, while warming has been a central concern, activists underestimated the complexity of ocean-atmosphere interactions, such as those involved in El Niño and La Niña events, which have profound effects on global weather patterns. Changes in ocean currents can alter these phenomena, leading to unpredictable shifts in droughts, floods, and storms, which were not adequately factored into earlier climate projections. Failure to anticipate the impact of polar amplification. The concept of polar amplification, the idea that the poles warm faster than the rest of the planet, was well understood in the scientific community but often misunderstood by climate activists. While activists accurately highlighted the rapid melting of polar ice, they did not fully account for the intricate ways in which this would affect ocean currents. Melting ice sheets in Greenland and Antarctica are introducing vast amounts of freshwater into the oceans. Freshwater is less dense than saltwater, and its influx can disrupt the thermohaline circulation by preventing the dense, salty water from sinking and driving the currents. The consequences of this are complex. Rather than a straightforward cooling or warming effect, it may lead to regional climate shifts that were not anticipated. For example, while parts of the North Atlantic could cool due to a weakened current, other areas might experience more intense heat waves as a result of changes in atmospheric circulation patterns. Additionally, the impact of melting polar ice on sea level rise has been uneven. Activists often frame this as a uniform global threat, but regional variations in sea level changes, driven by factors like ocean currents, were not always included in the public messaging. As a result, coastal communities in different parts of the world have experienced sea level rise at different rates, with some regions, like the Western Pacific, facing more immediate threats than others. Underappreciation of the ocean's role as a heat buffer. Another area where climate activists have occasionally fallen short is in recognizing the ocean's role as a heat buffer. The ocean has absorbed over 90% of the heat from global warming, which has had a somewhat moderating effect on atmospheric temperature increases. However, the long-term consequences of this heat absorption were not always clearly communicated. By focusing on atmospheric temperature targets, such as the goal to limit warming to 1.5 degrees Celsius, activists often neglected to highlight how ocean heat storage could delay or mask the full extent of climate impacts. The heat stored in the deep ocean is essentially hidden from surface measurements, meaning that even if we meet temperature goals, the deep ocean could continue to warm, with delayed consequences for ocean currents and marine ecosystems. This slow release of heat from the ocean back into the atmosphere over decades or centuries could create long-lasting climate impacts that activists did not account for in their campaigns. Political messaging versus scientific uncertainty. Finally, one of the challenges climate activists have faced is balancing effective political messaging with scientific uncertainty. In the quest to galvanize public opinion and influence policy, some activists have simplified the science of ocean currents and climate change to make it more accessible. While this has been successful in raising awareness, it has sometimes led to overconfidence in predictions and models that are inherently uncertain. The science of ocean currents is complex, involving multiple variables that interact in unpredictable ways. Activists, however, often needed to present clear, urgent calls to action, which sometimes resulted in underestimating the range of possible outcomes. As new data emerges, it is clear that while ocean currents are indeed changing, the pace and magnitude of these changes are less predictable than originally thought. The failure to adequately communicate this uncertainty has, in some cases, led to disillusionment and skepticism about the broader climate movement. Over the last 20 years, climate activists have made significant strides in raising awareness about the role of ocean currents in global climate systems. However, certain assumptions and simplifications about the behavior of these currents have not held up to scientific scrutiny. The reality is more complex than the often linear, cause and effect models that were promoted, and future activism must embrace a more nuanced understanding of ocean dynamics. As we continue to learn more about how the oceans respond to a changing climate, it is crucial to incorporate this knowledge into climate action plans, ensuring that future strategies are grounded in the latest science.